These are our notes on 2.3 for Wednesday, and we're going to be working with what's called a biconditional statement, and then we'll also talk about what we would call a good definition. But before we do that, yesterday we went through in 2.2 that once we have an if-then statement, sometimes we'll call that, don't write this on your notes, but if P, then Q. And P could be the statement, if I'm sad, Q could be the statement, then I cry. And we said that we can take three versions of this and give them different names. One is called the converse, which I call the swapper, which just swaps those. So if it was, if I cry, then I'm sad. The swapper becomes, if I'm sad, then I cry. We call that the converse. That's the one we'll be working with our biconditional statements today. We're actually going to be working with both of these together. But to keep going from yesterday's, we also have what was called the inverse, which doesn't swap the if and the then. It just negates or nots both of them. I call it the notter. So if I cry, then I am sad, becomes if I don't cry, then I'm not sad. Okay? So, and then we also had the one that swaps them and nots them. Those were yesterday's. We called it the contrapositive. But today, we're going to be working with the original if-then and its converse, which would be the swapper. When we work with those together, we can make what's called a biconditional statement. So I Googled it and gave you the definition from Wikipedia. It says a biconditional statement is a combination of a conditional statement. Let's go ahead and say what we know about a conditional statement. That is the original if this, then that statement. Or the P implies Q statement. And its converse. Let's take that word from yesterday. That's the swapper. So that would be Q implies P. Written in the if and only if form. Okay, so what does that mean? It means we are going to take the original statement. So I'm going to write that down. Suppose I'll use the cry and sad. I'm going to say, if I am sad. And if you don't want to write this, that's fine, but make sure you're taking it in. If I am sad, then I cry. That is my original conditional statement. And I'm going to take its converse, which means I'm going to swap them. If I swap them, cry, then I am sad. So that's what this means up there when it says a combination of the conditional statement, check, and its converse, check. Now it says written in the if and only if form. So the biconditional statement will combine these two and connect them. So we're going to chuck the if and the and just say, you know what? I am sad. If and only if I cry. And I just link them. The trueness of it. So you'll notice that, and I could have said it either way, but I am sad if and only if I cry. So I make one statement out of the two, and that's what it means by written in the if and only if form. Now the trueness of it, do I cry if and only if I'm sad, or am I sad if and only if I cry? I cry when I peel onions, but I mean, we're not going to worry about that quite yet. When we have those questions, it'll be very clear whether it's true or not true. So I just told you a biconditional statement deals with the original and its converse. And then we connect the two with the phrase if and only if. So let's go up here. It says, you will need to be able to construct and deconstruct. So basically make one out of two statements, and given one, break it into its two statements. So each conditional statement below is true. All right, let's read it. If an angle measures 47, then it is acute. True conditional statement. If angle measures 90, then it is a right angle. True statement. It says then we write the converse. So above that, let's remind ourselves that that means we need to swap the if and the then, or we need to reverse it so it's P implies Q, Q implies P instead of P implies Q. So let's go up here and read it. If an angle measures 47, then it is acute. All right, my converse, I'll write that over here, is going to swap those. If my subject is an angle, is swap it. Acute, then, and again, pause the video if you can't keep up with the speed of the writing. Then it measures 47 degrees. That's the original and the converse. Then it says to combine them as a true biconditional, but only do that if the converse is also true. So let's go read that. Is it true that the original is true? If an angle is 47, then it's acute. If an angle is acute, am I 100% sure it's 47? This guy is truth value, or it would be called a false statement. So therefore, I can't write the true biconditional, so I just move on to the next one. Because it says, if the converse is also true, combine the statements. My converse was false. So let's go to letter B, and you have more room on your worksheet than I gave myself on these notes. So I'm going to have to squeeze it in over here. But my converse would be, swap these out, okay? The if and the then. So I still have if and angle. I still need the subject to my sentence. I'm talking about angles here. So if and angle, but I'm not going to say measures 90 degrees. I'm going to do the converse. Is right, or is a right angle, but I'm just going to write right. Then it, swap them, measures 90 degrees. It says in the directions, if the converse is also true, so I have to make sure in my head I think that's true. If an angle is right, am I 100% sure it's 90 degrees? Yes. Then I'm going to combine them to write a true, I'm just going to cross this out for now and we'll answer it in a little bit, just because you don't do this in your notes. You have plenty of room. I just don't. So it says combine them. Well, remember it said that we combine them with that phrase, if and only if. So I'm going to take this if and take it off. I'm going to take this then and take it off. And I'm just going to start with an angle is a right angle if and only if it measures 90 degrees. So I'm going to go back to the vocabulary of this. We have a true conditional statement, a true if-then statement. We wrote its converse. We swapped the if and the then. The converse was also true, so we combined it to make a true biconditional statement. When the biconditional statement is true, then we can answer this question. It says, which statement above could be in a dictionary as a definition? And it would be the second one. The definition for a right angle. The measures of right angle means it is 90 degrees. It works forward and backwards. If it's 90, then it's right. If it's right, then 90. For acute, I cannot have this be the definition of an acute angle. It would not say, if an angle is acute in the dictionary, it would say it measures 47. It'd have to say it measures less than 90. So again, to be a good definition, they have to be true, forwards and backwards. The original and the converse. So, last page. It says, write a conditional statement and its converse. So I'm going to deconstruct this. So now I see this phrase, if and only if, and I'm going to break it into its two statements, the original. I'm just going to put the word if in front of this. If an angle is obtuse, is obtuse, chop the if and only if I'm deconstructing it. If an angle is obtuse, then let's just say it measures. I'll be a good girl. It has a measure. Again, if you're watching these notes, you just go ahead and pause the video. I wrote slower in class. Greater than 90 degrees. That's one of them. The converse will swap those. So I still have my subject of an angle. If an angle, stop and swap, not is obtuse, but has a measure greater than 90 degrees, then it is obtuse. So weird in math, right? I don't know where my numbers going on here. Don't like numbers, you love this chapter. You love numbers, you might be a little miserable. Alright, so again, I deconstructed it. I was given a biconditional statement. It's two of them connected with if and only if. When I deconstruct it, I do it forwards. If an angle is obtuse, then it has a measure greater than 90, and then I swap them for the converse. If both are true, it's a true biconditional statement and a good definition for an obtuse angle. That would say in the dictionary, obtuse angles, and it'd say angles that have measures greater than 90. It's because it works or is true both ways. So now we'll try it in multiple choice. So it says to write them, which is a pain in the butt. It's a lot easier if we play the multiple choice game. So let's try that because I don't want to write all this out. So for part B, I'm going to pick which one of these has deconstructed my biconditional, my if and only if statement, into its original and converse. So it has to start with an if, right? If I drink milk, both are good now, then it's lunchtime. So both of these are in and running. Then I have to swap them and write if it is lunchtime. That has nothing to do with juice. This one's ridiculous. So this would be B. That's the correct original and converse. And if I asked you if I could put that in the dictionary, if it's a good definition of milk for lunch, it wouldn't be, right? I drink milk sometimes when it's not lunchtime, but that wouldn't be asked because it's too ridiculous. The one about the angles was a good one. So let me see if I'm done here. And no, I'm not. I'm on B. It says, again, we would call something a good definition if it could be put in a dictionary. And to be good, a conditional statement, which again is a if this, then that statement. We sometimes say P implies Q. Must be true forwards and backwards. Okay? So you in your head, when it says, is this a good definition? You're going to say, if an animal is a dog, then it has a tail. I'd agree with that. If an animal has a tail, then it is a dog. Not true. Okay? So is this a good definition? No. If not, explain. You could just give a counter example. Cats have tails. It didn't work backwards. Okay? Let's go read the next one. If an angle measures less than 90, then it's acute. If an angle is acute, then it measures less than 90. This is working both ways, right? This would be a good definition. If an angle is acute, then it measures 90. If it less than 90, if an angle measures less than 90, then it's acute. It flows truthfully forwards and backwards. So yes, we could put this in the dictionary as a good definition for an acute angle. So the next thing we're going to do is I pass out worksheet 2.3. You can find that in our worksheets folder in Schoology. And we did the starred ones together. So if you have a printer at home, print them off. If you don't, you can always just do it on a separate sheet of paper and turn them in. So let's go take a look at, get to the end here where I put the assignment. they always come in and toss themselves right into the end. So the starred ones we're going to do together, just to make sure that the short notes were enough for you. All right. Each if-then statement below is true. True. Sweet. Write its converse. All right, so let's go do that first for this star problem. Converse swaps the if and the then. So I'm going to say if, but I'm going to swap these two out. So what's my subject? Two segments. But I'm not going to say have the same length. I'm going to swap it and say are congruent. Let's use a symbol for that. Okay? That'll save us some writing. If two segments are congruent, then they have the same length. Alright, so the original was given to me, said it was true, right? I wrote the converse. I have to decide if I think it's true. So, oops, I forgot the F on my thing. If two segments are congruent, then they have the same length. Totally true. So now it says, if the converse is also true, combine them as a biconditional. So remember for the biconditional, don't you do this, but we toss the if and the then, don't you go cross them off, and we just start our phrase. Two segments. We'll say are congruent, but then we use the phrase if and only if they, and then you can finish off, have the same lengths. You go ahead and write that out. You can pause if you want to. So follow the directions on that. There's not very many. I cut the worksheet down because that writing can sometimes really be, it just gets old writing so much. So I really tried to shorten the worksheet, but then we really have to make sure we're paying attention. So now this one says write the two statements that form each conditional. So I'm going to have two if-then statements that I'm going to write. A line bisects a segment. So I'm going to say if a line bisects, because this is where we chuck the if and only if. If a line bisects a segment, right? Then, intersects. And you're going to finish the sentence. The segment only at its midpoint. Pause the video and finish writing the sentence out. I don't need to. I'm just making sure you understand the directions. Then, statement number 2 will be the converse. So what we will do is we will swap our if and then. So we will say if, then, what do I have here? If the line bisects a segment, then the line intersects. So I'm going to say if a line intersects the segment, just write say, only at its midpoint. Then, and I'm reversing them, it bisects a segment. So then we can say then it, or then the line, probably say that it bisects the segment. So now we are deconstructing them. Alright, so I did one with you where you had to write it, and one where you had to take it apart. And now we'll do number 8. Test each statement to see if it is reversible. That means if you swap it or write the converse, is it true? If two angles are a linear pair, then they are adjacent. True. If two angles are adjacent, then they are a linear pair. Not necessarily true, right? From last chapter. So this says if so. So this one would be not reversible. I found a counter example. I found a pair of adjacent angles right here that are not a linear pair. But if they are both true, all right. So let's go to the next one. It says, is each a good definition? So we have to check it both ways. If an animal is a cat, then it has whiskers. I agree. If an animal has whiskers, so I'm swapping it, than it is a cat. I don't agree. I can give a counterexample. So just go ahead and give me an animal that has whiskers that's not a cat. You could say, I don't know, a mouse, a seal. I'm just going to put a mouse. All right? So you're, looks like you've got one more star upon Mars down here. Write each true statement as a biconditional using the phrase, and our phrase is going to be if and only if. That's what we use. So I already kind of typed the first one on there because I didn't want to write it out loud. But it says points in quadrant 3 have 2 negative coordinates. So I'm going to say a point is in quadrant 3 if and only if it has 2 negative coordinates. Alright, so I give you a sample of each one because I think the directions, you really got to read these bolds up here. So when it says as a biconditional in our notes, that means we use and link it with the phrase if and only if. Alright, so a lot of writing, but not too difficult, right? Anyway, have a good one.